Today we will see the Boolean operation and expression, and we will see some laws and rules of Boolean algebra. Okay, so you all have know that in our Boolean algebra that we will use this some gates and or NAND or like these gates in our Boolean algebra. So in Boolean algebra there are some basic terms that you should know. What are those? One is variable, second one is complement, and third one is literal. Okay, so let me tell you what is that. A variable means it is a symbol. Okay, it is a symbol which represent some data or some relation between any two, or it is nothing but represented by an italic uppercase letter, means it can be A, B, C, D, any variable. Okay, these are the variables. Next one is complement. Complement means, you know what do you mean complement? Complement means to take the inverse, take the complement of A, means A, if this is A, the complement will become A bar. So it is represented by bar or not. Complement is represented by bar or not. Then third one is literal. What do you mean by literal? Literal means it can be variable or complement of a variable. It means, what do you mean by literal? Literal can be A or it can be A bar. It can be C, it can be C bar. Okay, so literal can be anything, either once A or A bar, or any variable or complement of variable. So these are the three terms, that the basic, just some theory term that you know in a Boolean algebra. This is called variable, means this is a symbol which represents some data or some relation between any inputs, or these variables can take either any single variable. A can take a value 0 or 1. This B can take a value 0 or 1. Okay, and complement, you know, by putting a bar, or that I can, this is called not A or A bar. Okay, third one is literal. Literal means it can be A or A bar. Now in our Boolean algebra, so in Boolean algebra, what we will see, our sum term can be represented by sum of literals. Like in logic function, how our sum term is represented? Sum term is represented by by OR gate, OR operation. So here in our Boolean algebra, sum term will be represented by number of literals. Okay, that is A plus A bar, B plus C bar plus D. This is one literal, this is one literal, this is one literal. So they are combined, they are summed to give me this Boolean algebra summation. Now tell me, so my sum term will become 1. How? When my sum term will become 1? If any of the variable or any of the literal is either 1 or all are 1. It means if this is A, this is B, this is C. When this A plus B plus C will become 1? When if either A is 1, then B is 0, C is 0, then only it will give me 1. Or A is 0, B is 1, C is 0, then also it will give me 1. Or A 0, B 0, C 1, that is also give me 1. Or 1, 1, 0, that will also give me 1. 1, 0, 1, that will also same. 1, 0, 1, 1, that is also same. 1, 1, 1, this will also give me value 1. It means in a Boolean algebra, my sum of literal will give me 1. When? If either any of the input is 1 or all are 1. You see, any one, 2, 1, 2, 1, 2, 1, or all are 1. At that case, my output will become 1. And when this A plus B plus C will become 0, A plus B plus C will become 0 when? When my A equal to 0, B equal to 0, C equal to 0. This is the only case for addition, then only my output will become 0. If you remember in our logic function, in our Boolean addition, like in binary addition, 0 plus 0 gives me value 0. 0 plus 1 is nothing but 1. 1 plus 0 is nothing but 1. 1 plus 1 is nothing but 1 0. This 1 0 is represented by 1, means it is a high value. It means when any of the input is 1 or both are 1, then only my output is 1. And when my both input are 0, then only my output is 0. Okay, you see. So this is the, in binary algebra, this is the sum of literals. Let me write you in terms of complement also. So this is also one summation, A bar plus C, because it is sum of literals. It is literal, it is literal, it is also literal. Literal means a variable or a complement of a variable. Okay. Now you tell me when this value will become 1, Or let me tell you when this value will become 0. When this value will become 1, if either a equal to 1 or bc may be any value, or b equal to 0 or ac can any take value, c equal to 1, then also possible. Now tell me when this value will become 0. When? If a equal to 0, this literal also give me 0 and c also 0. It means when these three conditions are applied, then only my output will become 0. It means my a should be 0, c should be 0 and b should be 1. Why? If b will 1, then b bar will give me a value 0. Point here that this b value should be 1. Why? If b value will become 1, then only 1 bar, which is nothing but 0. And then it is possible 0 plus 0 plus 0 will become 0. If I will take my b equal to 0, then what will happen? Let's take a equal to 0, b equal to 0, c equal to 0. Then a is nothing but 0. Plus b bar means the bar of 0, which is nothing but 1. Plus c equal to 0. It will give me a value 1. It will not, neither it is going to give me a value 0. Okay. So for that, remember, when a bar is there, you have to take the inverse. Since here a and c are 0, for b you have to take the inverse of 0, is nothing but 1. Let's take another example. Let's a plus b bar plus c bar plus d plus e bar. Now tell me when this value will give me 1. Simple. Either a is 1 or b, c, d, e any value. Or b is 0, a, c, d, e can take any value. B, c, d, e. Because if b will 0, this value will become 1. And if this value 1 will become 1, whatever may be the b, c, d, e, it doesn't matter. Means for our OR operation, if any one input is 1, my output will become 1. That's why I have to make my b equal to 0. If b equal to 0, then only b bar will become 1. And since this literal equal to 1, my output will become 1. Or third case, c should be 0. Similarly for c also, whatever may be the value of a, b, d, e does not matter. If once my c will become 0, my output will become 1. Because c equal to 0 means c bar will give me a value 1. Okay. D value should be 1, or a, b, c, e can take any value, or my e value should be 0. These are the conditions for 1. Now tell me what is the condition for this summation. Sum should be give me a value 0. When? This value should be 0, 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 this also should be 0. It means my a equal to d equal to should be, a d value should be 0, b equal to c equal to e equal to should be 1. Why? If b, c, e will become 1, then only b bar, c bar, e bar will give me value 0. It is the only criteria that is possible. B bar, c bar, d bar will become 0 when b, c, e will give me value 1. Okay. So this is for the sum term. Now in Boolean multiplication, like in logic function, how we can represent our Boolean multiplication? It is the multiplication of literals. Like in logic function, how we represent our multiplication? That is by AND operation. That is nothing but a dot b or a and b. Similarly, here also our Boolean multiplication is nothing but multiplication of literals. Means it can be a dot b bar dot, or this is dot means AND operation. C dot d bar dot e bar can take any number of input. It can take a, b bar, c. It is possible. A, c bar, d. This is also possible. Okay. So it is nothing but the multiplication of literals. This is one literal, this is also one literal, literal. This is a multiplication of literal. Okay. Now tell me when this, let's take example a, b bar, c. This value should be 1. Then what are the conditions for a, b, c? Then this value will become 1. Since it is a AND operation, when my output will become 1? If my output will become 1 only when my all inputs are 1. It means my a value should be 1, sorry, this literal should be 1, this literal should be 1, this literal should be 1. When my three literals will become 1, then only they will multiply to give me a value output equal to 1. It means a equal to c equal to 1, b equal to 0. Why? If my b will 0, then b bar will become 1, and then only it is possible 3 input 1 and will give me output 1. Okay, so you have to see the multiplication, see the literals in which way they are arranged, accordingly whether they are in normal form or they are in the complement form. Accordingly you have to choose your a, b, c value. Okay, it means how it is represented. This is a, this is b, we have taken one complement of b, and c, then we have then we have ANDed these three. A, this is B bar, this is C, will give me value A, B bar, C. Okay, this is represented like this, they are represented like this. This is the Boolean operation and expression. Now we will see some laws and rules of Boolean algebra. There are basically three laws for this Boolean algebra. What are that? One is commutative, one is distributive, and third one is associative. One is commutative, one is associative, third one is distributive. Okay. So you all are aware of these three in your mathematics. What is a commutative rule? So for this Boolean addition, the commutative rule is nothing but A plus B is same as B plus A. It means in which order you have ORed, that is ORed, means I have taken two input, I did the OR operation, that is ORed. ANDed means I have taken two input or three input, whatever may be, and I have AND them. I did the AND operation. Okay. So in which order my inputs are ORed, it does not matter. If this is A, B, they are ORed in this way, A plus B, and the output is same, will be B plus A. So you see, if this is A, this is B, this is the OR operation, that is equal to A plus B. This is B, this is A. Now this is the OR operation, nothing but B plus A. So how we can come to know that whether these two are equal or not? You can draw the truth table. This is A, B, 0, 0, 0, 1, 1, 0, 1, 1. This is A plus B, 0, 1, 1, 1. Now this is B, this is A, this is B plus A. 0, 0, 0, 1, 1, 0, 1, 1, 0, 1, 1, 1. So you can see my output of these two are same. This one simple one. Okay. This is the commutative rule for this Boolean addition, that A plus B is nothing but B plus A. That my order does not matter in our OR operation. Similarly, this is commutative addition. Similarly, commutative multiplication also. Multiplication, it means A dot B is nothing but B dot A. Dot I am saying why, it means AND operation is there. A and B is same as B and A. If this is A, B, they are ANDed together, it's same as this is B, A, they are ANDed, will give me the same value. Okay, you take any value, this is 0, this is 1. What will be output? Output will become 0. Here B is nothing but 1, A is nothing but 0. So 1, 0 will give me value output 0. Okay, so this is the two for Boolean addition and multiplication, that is for commutative. Next one is associative. Associative means A plus B plus C is same as A plus B plus C. This is the associative rule for addition. You know all things, that I am recalling for you guys, that if I am doing OR operation, that is more than two variables. Here is one OR operation, here is one OR operation, that is three variables are there. So when I am doing OR operation, that for more than two variables, my sequence or my order does not matter. It means if this is A, this is B, this is C, first I will do the OR operation of B and C, then I will take the two output, again one OR operation. This is nothing but A, this is nothing but B plus C, will give me A plus B plus C. Okay, this will be the same for if I will do the A first, A, B OR first, then with the output I will combine with C, again one OR operation. So this will also give me the same output. It means if I draw a truth table of A, B, C, since there are A, B, C, how many possible input combination? 8 input combination. 0, 0, 0, 0, 0, 1 till 1, 1, 1. There are 8 possible combination. So first you do the OR operation of B and C here, OR operation. Now then do the OR operation with A. Whatever the output that you will get, here you will get B plus C. So with this output you do the another OR with A, you will get this output. Similarly, first you do the OR operation of A and B, and you do then with C, you will get the same output. This is a simple one. I am not doing honestly over here. It will take much time because there is no need of that. Just remember this property. You will use this property while solving some difficult questions, some difficult numerical. You might need this property. Okay. no need of any this derivation or any truth table matching. Just to remember, if you will do by yourself also, you will get the same answer. A plus b plus c is nothing but a plus b first combined then c. This is the addition of associative. Then second one is the multiplication. It means a into bc is nothing but ab and c. Means first I am doing the AND operation of bc, then I am doing AND with a. Is the same as if first I will do the AND operation between a and b, then with c. It means if I am ANDing more than two input, then my order also doesn't matter. It means here is a, here is b, here is c. You take bc first and then output of this one make another AND gate with a, will give me value a and bc. Here bc I have put in bracket, means they are first ANDed. It's same as if we first do the AND operation between a and b, then the output is ANDed again with c. It will give me the same value, whatever the truth table for this 8 inputs will do the same for this one also. Okay, so this is the associative law for this addition and multiplication. Next we will see the distributive law. What do you mean by distributive law? If first it is an odd, then it is ANDed. Okay, when two inputs are odd and the output is ANDed, then it will not affect my output if I will first AND each term with the another two input and then I will take the OR operation. It means if I will first AND AB and I will AND AC and then I will OR AB plus AC, is same as A ANDed with B plus C, means B or C. You can see the truth table. Let me draw the truth table for this one. Okay, A B C 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. How I told you to write the sequence 0 1 0 1 0 1 0 1 2 0 2 1 2 0 2 1, then 4 0 4 1. Okay, if there is another input that is present at the left of this one, let's take an E or D, then there will be 8 0 and the next 8 will be 1 if there are 4 input. Similarly here there are 4 0 4 1, again 4 0 4 1, here 2 0 2 1 2 0 2 1 0 1 0 1, like this. Okay, so you will represent in a question, if there are given the 2 input or 3 input, you have to write the truth for this table, you have to make this way. Now what I have to do, first I have to take the B plus C, means odd operation of B C. You see 0 0 output will 0, 0 1 output will 1, 1 0 1 1 1 1, again 0 0 0 1 1 1. What I did, I have just odd these two input A and B, sorry B and C, and B and C, when my both inputs are 0, at that case only my output is 0, and in all other case my output is 1. Now I have to AND with A, I have to AND with A, the output of B and C I have to AND. Now 0 dot 0 is nothing but 0. Since there are 4 0 in a way, in a line, whatever may be the second input, now it is a AND gate. When my one input is A, second input is B and B plus C. Okay, so if any one input is 0, then output will become 0. Similarly here 4 input are 0, then my 4 output will become 0. This 4 with this 4. Now 1 0 output is 0 because it is AND operation. 1 1 1 1 1 1. Since all input are 1, output will become 1. Okay, so this is the output of my this one, this A plus B, A dot B plus C. Now let me draw this second RHS side. First I have to find AB, then I have to find AC. What is AB? Or AND operation of this one, 0 0 0 0 0 0. So first 2 0. Then since there are 4 0 in this side, whatever be the value of B does not matter. This 4 0 multiplied with any value will give me 0 output. Okay. Now 1 0 will give me value 0. 1 0 0. 1 1 1 1 will give me value 1 and 1. When both input are 1, then my output is 1. Okay. Now the AC are to OR 0 0 0. Since there are 4 0 for A, the first 4 will be 0. Okay. Now 1 0 is nothing but 0. 1 1 1. 1 0 0. 1 1 1. Now I am going to add these two, which is nothing but my this value AB plus AC. So you see, now I am going to add these two, 0 0 0 0. This is 0, this is 1. 1 0 means it is 1. This is OR operation. 1 0 means 1. 1 1 means 1. Okay. So you can check. This is the output of my RHS AB plus AC. This is the LHS A into B plus C is same. 5 0 in a row, then 3 1. 5 0 in a row, then 3 1. Okay. So this is the three basic rules that we might need in our next chapters. This associative, distributive, and commutative. Okay. Now let's see some rules, and now already we completed the laws. We'll see some rules. So what are the rules? There are 12 basic rules that we need in our Boolean algebra. First one is A plus 1, whatever the value that we'll see. A dot 1 12 A plus B into A plus C. Okay, these 12 are some basic rules of our Boolean algebra that we need to solve any type of numerical based upon this Boolean algebra. Now let me start from the first. A plus 1, it is OR, there is a OR operation. Here is a OR operation. This is A, this is 1. One input is A, second input is 1. Now tell me, if I will apply a 0 for A, then what will my output? Is nothing but 1. Since this is 1 0, output is 1. If my A is 1, then 1 1 will also give me 1. It means my A plus 1 will always give me value 1, whatever may be the value of A. Okay, this point is clear, or whatever may be the value of A, my A plus 1 will give me value 1. Now tell me, A plus B plus 1, what will be the value out? What will be the output? It will be also 1, because whatever may be this A B value does not matter. Anything that you write, any number of input, A plus C D plus D E plus A C D E, let's take plus 1. Once you will add any number of input with 1, you will get a 1 at my output. Okay. So this is the first property of our Boolean algebra. Next. This is A, this is 1. Now tell me, if A equal to 0, one input is 0, second input is 1, output will become 0. Yes or not? For AND gate, if one input 0, second input, output will become 0, whatever may be the second input. Now if A equal to 1, then output is nothing but 1. Okay, because 1 and 1 will give me an AND with value 1. It means A dot 1 will give me a value A. Whatever will be the value of A, that will be the output. You see, if my A is 0, my output is 0. If my A is 1, my output is 1. Okay. Now, the third one. It means A dot 1 equal to A means, if I write ABC dot 1, that will also give me value ABC. Anything that is multiplied with 1 will give me the same number. Now, A plus 0. It is A, it is 0. Okay. A plus 0 means, if A equal to 1, what will be the output? Output will become 1, because it is OR operation. Now, A equal to 0. So what will be the value of output? At the output, 0 plus 0 will give me value 0. So you see, A plus 0 gives me a value A. A is 1, output is 1. A is 0, output is 0. Now the fourth one. Let me draw it here. No need to write again. It is 0. If A equal to 0, it is one input is A, second input is 0. Now if A equal to 0, output of OR gate will be 0. If A equal to 1, what will be the output of AND gate? So this is AND gate, output also become 1. Since one input is 0, whatever may be the possible input, output will always be 0. Since one input is 0. Okay. Now, A plus A. A plus A. This is A plus A, or operation of two input, that is A. It means if A equal to 1, this is 1, this is 1. So 1 will give me value 1. If this is 0, 0, 0, 0, 0 or will give me value 0. Are you getting or not? If A equal to 1, then output will 1. A equal to 0, output will 0. Means A plus A will give me value A. Okay. Now, A plus A bar means one input is A, second input is A bar. If A equal to 1, what will be A bar? A bar will become 0. 1, 0 odd will give me value 1. Now, if A equal to 0, what will be the A bar? A bar is nothing but 1. Then 0, 1, same, odd will give me value 0. It means A plus A bar always going to give me a value 1. Similarly, if I will ask what is B plus B bar, is nothing but 1. C plus C bar plus D bar is nothing but 1. Because C plus C bar is 1 plus D bar is 1. Then we can apply this property. You see this property. Whatever is the second input, if any one input is 1, 1 plus anything will give me value 1. Okay. We are going to use this property, these rules. Yes, these rules. Now, the sixth one. A dot A. A dot A means if A equal to 0, this is 0. 0 dot 0 is nothing but 0. This is output is 0. This is 1, this is 1. Output will become 1. Because 1 dot 1 and 1 means give me output 1. It means A dot A will always give me a value A. You see, if A equal to 0, output is 0. A equal to 1, output is 1. Okay. Now, A dot A bar. If A equal to 1, A bar will become 0. 1, 0 will give me output 0. Okay. If A equal to 0, A bar will become 1. Then 0, 1 will give me a output also 0. Okay, don't confuse. The first one is A equal to 1, second one is A equal to 0. Then also my output is 0. It means A dot A bar always going to give me a value 0. Fourth one. A bar bar. It is a double bar. Means here it is the A input. First applied to a NOT gate. That is 1 bar. It is nothing but A bar. Again what I did? I applied another OR gate. Another NOT gate. It is nothing but A bar bar. So A bar bar. You see, if we applied 1 over here, what will be the A bar? It is nothing but 0. Again this 0 is applied to our NOT gate, is nothing but 1. It means whatever is the output will be same as the input. Means A bar bar is nothing but A. If we apply 0 over here, what will be the output of this first NOT gate? 1. Again the second NOT gate, it will 0. You see, A. Whatever the input, A bar bar will be nothing but same. So this is nothing but A. Okay. Now the 10th one. Now the 10th one is nothing but A plus BC. No, it's A plus AB, not BC. It is A plus AB. Okay. So what do you mean A plus AB? Here I am going to take A as common. So what it will remain? It will remain 1 plus B. Okay. What I did, I just took common A from both. One from here, one from here. So it will left 1 over here and B over here. Now, using the first property, 1 plus B will give me a value 1. Because this is the first property, A plus 1 plus B is nothing but 1. Now, A dot 1. Now, I am going to use the second property. Here I applied the first property, here I am going to use second property. A dot 1 means it will give me value A. It means A plus AB will give me a value A. Okay. Remember, this is one important property we are going to use everywhere. A plus ABC plus ACD. What will be the value? I will take common A from here. 1 plus BC plus CD. Since something is added with 1 means that output will give me 1. Because this is the OR operation. 1 input 1 means output will become 1. Now A dot 1 will give me value 1. That means this value will give me value 1. Okay, so remember A plus AB or A plus ABC plus ACD plus there is long term, but in each term A is there, then the output will become A. You can draw the truth table also. If this is A, this is B, I have to find AB, then I have to add these two. So 0 0 0 1 1 0 1 1. What is AB? 0 0 0 1. Now I have to OR A plus AB. A plus AB. 0 0 is 0, 0 0 is 0, 1 0 is 1, 1 1 is 1. So you can check 0 0 1 1, 0 0 1 1. My A plus AB is nothing but my A. Okay. Now the second one, 11th one. A plus A bar B. Okay. We have to solve this. So for solve, I can use these rules. Now you tell me in place of A, can I write A plus AB? In place of A, I can write A plus AB plus A bar B is there. Okay. Now you see this A, can I write in place of A is nothing but A dot A. This A is nothing but A dot A plus AB plus A bar B. Now I am going to add this 0, A bar B plus 0, something 0 is there. It means I can write AB, AB plus A bar B plus in place of 0 I can write A bar. Okay. Then if I take common A from here, what would be left? A plus B. If I take A bar common here, what would be left? A plus B. Okay. Now it looks like C into D plus, means A into B plus C into B. Both B are, A plus B will taken common outside. Both are there. And it will left A plus A bar. What is A plus A bar? Which is nothing but 1. So A plus B dot 1. If any number is multiplied with 1 means it will give me a value A plus B. It means A plus A bar B can be written as A plus B. I did just all these derivations just to make you clear that how this is formed. What I did, in place of A, I replaced A plus AB using this formula, using rule 10. Now, in place of A, what I wrote? I wrote A as A dot A, rule 7. Now, I added rule 8, means in place of 0, it is nothing but 0 is there. So I can write 0, in place of 0, I can write A plus A bar. Because if I add 0 to any number, it will not affect. You see, rule 3 is saying, rule 7 plus rule 3 also. Rule 3 is saying if I will add A plus 0 is nothing but again A. So whatever is the value, if I will add 0, it will not going to change anything. Okay. So in place of 0, I can write A dot A bar. Then it become easy for me to take the common. And after taking the common, what I got? A plus B into A plus A bar. A plus A bar is nothing but, according to rule 6, is nothing but 1. Now according to rule 2, something dot 1 is nothing but same value. Okay. So from the truth table also we can see, if I take A, B, then A bar, then A bar B, then A plus A bar B. And I will compare this value with A plus B. 0 0 0 1 1 0 1 1. This is my input. Okay. I have to find this A plus A bar B. So how I can find A plus A bar B? I have A and B. I can take A bar. A bar is nothing but 1 1 0 0. Then I have to do one AND operation with B. So AND operation is nothing but 0 1 0 0. This is A bar B. Now I have to OR operation of these two. A bar B with A. 0 plus 0 is nothing but 0. 0 plus 1 1. 1 plus 0 1. 1 plus 0 1. Now I have to find A plus B. 0 plus 0 0. 0 plus 1 1. 1 plus 0 1. 1 plus 1 1. Now you can cross check. My A plus A bar B is nothing but same as A plus B. 0 1 1 1 0 1 1. Okay. So this is the irreducible rule is saying if something is given a plus a bar b, or I can say c plus c bar d is same as c plus d. C plus c bar d plus something is given. So if that term is there, we can take common. If it is given b plus b bar cd, then also what I can write? B plus cd. Okay. So this is the rule is saying a plus a bar b is nothing but a plus b. Now the last rule. Last rule is saying 12th one is saying a plus b multiplied by a plus c. First I will this is taken common, I will multiply each term. A dot a plus a with c plus a dot b plus b dot c. A with c, b with a and b with c. What is a dot a? A dot a according to rule 7 is nothing but a plus ac plus ab plus bc. Okay. Now can I take common a from these three? What is left? 1 plus c plus b plus bc. This is factorization. This is nothing but according to rule 7. Now 1 plus anything, what it will give me? It will give me a value 1. So I will get, in place of this bracket 1 plus c plus b, I will get 1 because 1 is added to anything, and plus bc. What is a? This is according to rule 1. Now a dot 1 is nothing but a dot 1 is nothing but a plus bc. This is rule 2. So this is nothing but a plus bc. You see what you have to do? You have just take first term as same and then multiply the last term. If I have c plus d into c plus e, then what I will write? I will write the first term c, then multiply the last two term de. This is the output of c plus d into c plus e is nothing but c plus de. Okay. Using truth table also we can prove this one. For 3 input 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. First I have to find a plus b. I have to add these two, a plus b. What will a plus b? 0 0 1 1 1 1 1 1. I did the simple OR operation. These two, a plus b OR operation. Then we will do a plus c. First and third one. 0 0 0 0 1 1. Again 0 1 1 0 1 1 1 1. Then 4 1. Okay. Then I have to do this 2 OR, means a plus b into a plus c. This side, LHS side. If I take the AND operation, 0 0 1 0 0, and there will be 5 1. 3 0 and 5 1. Okay. So this is my LHS. What is my RHS? 1 plus BC. So I have to find B into C. What is B into C? I have to take the AND operation of this one. So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 0 0 1 0 1 0 0 1 1 1. Now I have to add this value with this value. So 0 0 is nothing but 0. 0 0 0 0 0 0 0 plus 1 1. Now there are 4 1. Whatever the value does not matter since I am doing the OR operation. So that will be 1 1 1 1. Okay. So this is my RHS, right hand side a plus BC. This is a plus BC. This is the LHS. So you can compare. There are 3 zeros, 5 ones, 3 zeros, 5 ones. Okay. So these 12 are the basic rules. You remember these rules and try to practice in our question. Next, in the next video, we will see the De Morgan rule and we will apply these rules also.